Okay, so we're looking at the foldable. On the front side, it says, is the relation a function? This is the only page of the foldable we're going to fill out today. So first, if it is a function, here's how we tell. There's several different ways. The first way is, does every input have exactly one output? Now, inputs are x and outputs are y. And so it means that each value, each x value, I'm going to write this down. Each x value, all right, can only have exactly one y value. So like an x cannot be assigned, like if x is 3, 3 cannot have an input that gets you an output of 5, so, and then also gets you an output of 8. So, for example, if you had 3, 5 and 3, 8, those would not be a function because the x value 3 is assigned with two different outputs, which is the y value. So basically, your x's can't repeat. They can't have two different y values. So look at our first table right here. So this is a table format. So does each input have exactly one output? So this negative 2x is assigned to 3. There's no other negative 2's. This negative 1 has an output of 4. There's no other negative 1's. Here, 0 has an output of 5, and this 0 has an output of 6. So the input of 0 has two different outputs. So the x value is assigned to two different y values, and that's not okay. So this is not a function. So basically, it's not okay if the x values repeat with two different y values, but the y values don't matter at all. We could have every y value be the same number, and it wouldn't matter. Okay, look down here. This is an input-output table, like a mapping diagram. So what it means here is that the x is negative 1 and it gives you 4. Let's write that down. Negative 1, 4. What this means, the 3 is the x and it gives you 15. 3, 15. The 11, the arrow goes to the 15, so that means 11 is the x and it gives you a y value of 15. So now remember, we're only looking at the inputs. Does each input, each x value uniquely tie to a y value? So the x values are negative 1, 3, and 11. The x values do not repeat, so we're good. I see the y values repeat. There's two 15s, but we don't care if the y values repeat. So it is a function because your x values don't repeat, so that means each input has just one output. So you're kind of looking for, do the x values repeat? Okay, and then if it's a graph, we're looking for, does it pass the vertical line test? And basically, the vertical line test means when you draw a vertical line, and a vertical line is straight up and down like this, it can only go through the graph one place, like at each time. So no matter where you draw it, it can never cross the graph twice. So you guys see right here, if I draw a vertical line through this point, it doesn't pass another point. It's only passing that one dot. Here, only passes that one point, and so on. Each time I draw a vertical line, it only goes through the graph in one place. So this is, yes, it is a function because it passes the vertical line test. So now look at this graph over here to the right. If I draw a vertical line right here, do you see that it crosses the graph in two different places? And so that is, no, it does not pass the vertical line test, so it is not a function because the vertical line went through the graph in more than one place. And that's what the vertical line test is. And you can abbreviate vertical line test if you have to write an explanation as VLT, and I'll know what you're talking about. All right, let's look in our notes packet at 3.1 Day 1 notes, okay? So we're gonna use our foldable to answer some of these questions. They're pretty short. We're just practicing, is it a function? So, how to tell if a relation is a function. Does the graph pass that's the vertical line test. Sorry about that, guys. So, the vertical line test, meaning no vertical line passes through more than one point at a time. I'm having problems today. All right, so, and then do the x values repeat? Meaning if there's a 2, 4 and a 2, 6, one input, one x value has two different y values, and that's not allowed. All right, let's practice together. So down here on example 1a, we have some points. So is it a function? So do any of the x values repeat? All right, so it is not a function because right here you can see that the x values repeat. So we're going to say no. When they say, is it a function? We'll say no. And we'll say the x values repeat. Or one input of 5 has 2 different outputs. Okay, look at, let's do C next. I know we're going a little out of order, but is it a function? All right, and we're going to say yes, because when you look at the x values, each x value is different. So each x value is unique and doesn't, like, there's no input that has 2 different outputs. So yes, and I'm just going to keep it really easy here and say the x values don't repeat. All right, so now down here we have graphs. So you're going to use the vertical line test. So if you use the vertical line test on B right here, is it a function? All right, yes, it is, because it passes the vertical line test. I'm going to abbreviate VLT for vertical line test, because anywhere you draw a vertical line, wherever you draw it, it never goes through the graph more than one time. Okay, what about D? Is D a function? All right, so D is a function. I'm sorry, D is not a function. So we're going to say no. All right, it fails the vertical line test. So right here, when you draw a vertical line through it, it goes through in more than one place, and that's not allowed. The vertical line can only go through the graph in one place, so it fails the vertical line test. Okay, and last but not least, example 2 says make an input-output table for the function. So using these specific inputs, your table can go across like this with x's and y's, or it can be vertical. It doesn't really matter. So your x's, they told us your inputs are -2, 0, 2, and 4. And what you do is you can use a calculator and you just plug in your first input where x is. So right here, here's your equation. So x is -2, I'm plugging it in. And so then if you use a calculator, you're going to find out that that's 7. Now do it again, but plug in 0. And that's 3. Do it again, but plug in 2. And that's -1. And do it one more time, but plug in 4. Feel free to use a calculator for this. And that is -5. And that is an input-output table. You could also have it going this way if you would prefer. It doesn't really matter. But when they say make an input-output table for the function, that's what they're asking you to do.